Okay, I would like you to take out your notes and I'd like you to go to page, I don't even know what this is. This is page 8? I think it's page 6 or something. 7? This is at the top of page 7. So, when ionic compounds dissociate, read into that word split up, right? And when strong acids ionize, again, when they split up, it's important for us to understand what the concentration of the individual ions are, because it's the individual ions that actually end up reacting with other things. It's not the solute itself that reacts, it's the individual ions. So it's important for us to understand those concentrations. We have, in example 1, calcium chloride is dissolved into water to make a 0.10 mole per liter solution. Remember, that's of our solute. What is the concentration of each ion? Now, the first thing I want us to recognize is when calcium chloride splits up, it splitting up can be represented as a reaction, right? A dissociation equation. That's what I want you to write down right now. I want you to write down the dissociation equation for calcium chloride. If it were to split up, what would it split up into? You okay? Okay, why don't you grab a new note packet? Okay, well, why don't you grab a new note packet and then you can copy from yourself. Okay. Does anybody know what the formula for calcium chloride is? CaCl2. Cassidy? CaCl2. So we've got, we're looking for, okay, CaCl2. And so I'm going to start off as a solid because when I want to represent the idea of it turning from a solid into individual ions. Now, Shahad, it's important for you to understand that I would not mark you wrong if you started calcium chloride aqueous and turned into calcium ions aqueous and chloride ions aqueous. I need you to understand that, right? Now, there's a very obvious problem with what I wrote down. When this breaks apart, we end up with 2 chloride ions. So I'm going to draw a picture of this, and it's important for you to keep in mind the reason why we did that Lego activity is so that you have some sort of a visualization. When calcium chloride when this thing splits up, the calcium gets released from the chlorides, and the chlorides can now kind of individually float around. So if we started with a concentration of 0.10 moles per liter, I'm placing the original concentration directly under my original substance. Does that make sense why we're doing that? I want to say that this concentration belongs to this substance because that's the concentration we calculated using whatever math that we did. Now, when this thing splits up, what will the concentration of the calcium ions be? Because it's a 1-to-1 ratio. It doesn't matter specifically what the ratio is, it just matters that this coefficient and that coefficient are the same, right? So one of these makes one of these. 2 of these makes 2 of these. 0.1 of these makes 0.1 of these. I should say 0.10. Now, what's the concentration of the chloride ions going to be? Aaliyah? Double. 0.20 moles per liter. Now, was that pretty easy math for us? That was, yeah, probably pretty easy math. I'm going to show you the way we could prove it mathematically, and I want you to pay attention to the details. Because you know this is easy, what's going to happen here in a couple seconds? I'm going to make it significantly harder for you here in a couple minutes. But I'm trying to start you off with baby steps in the hopes that you will kind of understand what's going on. So what I want to do, let's ask ourselves, let's find the concentration of the calcium ions. Now, if you want to find the concentration in moles per liter of calcium ions, that's the way I want you to start it. You should have a little bit of room. We're going to do 2 of these. The concentration in moles per liter of calcium ions. Well, what do we want to start with? Moles per liter of what substance? Of calcium ions. So what we want to do, we want to start off with moles of calcium on top, and then we can put liters on the bottom. Now, I want to bring your attention to something that we haven't talked about in a really, really, really long time. It's something called the molar ratio. We talked about the molar mass pretty recently. We want to talk about the molar ratio. The molar ratio is always unknown over given, and it's the coefficients. What it means is for every 1 mole of this, how many moles of this are required? 1. So this is what I'm going to do. 1 mole of calcium, because that's our unknown, that's our concentration we want to get. It's unknown over given. What information was given at the beginning of the problem? The CaCl2. So 1 mole of calcium for every 1 mole of CaCl2. Now there's some really specific things in here. This number, this coefficient and the moles, they belong to the calcium. This number coefficient and the moles, they belong to the calcium chloride. What do we want on top at the end to finish off with? Moles of calcium, right? So we have moles of calcium. What do we want to cancel out here? Moles of calcium chloride. Do you see anything in here that has moles of calcium chloride? This thing belongs to the calcium chloride. So what we can do is we can multiply this by 0.10 moles of calcium chloride for every 1 liter. Now I know that that's a big leap. What we're starting to do is we're starting to attach units to very specific substances. But just kind of bear with me and we'll run through a couple examples. So what happens to my units? Do you see any units that cancel out here? Moles of calcium chloride cancel out with moles of calcium chloride. And so we end up with 1 times 0.1 divided by 1. So hopefully that's not surprising. You should get 0.10 moles per liter of your calcium ions. Does that make sense? Like when I go 1 times 0.1 divided by 1, what number do I get? 0.1. The ones don't matter. 1 times something and divided by 1 don't. That doesn't mean anything. Let's do the same thing. Hopefully you have a little bit more space. Let's do the same thing, but this time we want to find the concentration of which ion? We want to try and find the concentration of the chloride ion. Now we always want to start with what we want. What do we want on top here? Moles of what? Of chloride. Do you see anything in here that has to do with moles of chloride? 2 chlorides for every 1 calcium chloride. That's the molar ratio, and we're going to need that idea of the molar ratio quite a bit here. So we have 2 Cls, sorry, not 2 Cls, but 2 moles of chloride for every 1 mole of calcium chloride. Do not skip out on the details. If I write something down, please write it down because it's going to be important. Sorry, Brooklyn, you can't see Tammy. Okay, we want moles of chloride in the end. Well, that's what we want on top. So what do we have to cancel out?
Moles of chloride.
Moles of calcium chloride. Do you see anything referring to calcium chloride that has moles in it?
0.10.
0.10 moles per liter. So this concentration, because it belongs to the calcium chloride, 0.10 moles of calcium chloride per 1 liter. And what we end up getting is moles of calcium chloride and moles of calcium chloride cancel. What are the units that we're left over with? Moles per liter of what substance? Chloride. So we're going to end up with, when you do this on your calculator, 2 times 0.1, 0.2 divided by 1, right? So 0.20 moles per liter of chloride. Now, I totally understand. You're like, well, why did we do all of that work? How long did it actually take you to solve that problem? It took us about 20 seconds to solve this problem, right?
Yes.
But this is going to be really crucial here in a little bit, Wim. Yeah, and is the only way to get concentration are you always going to be given the concentration of a substance? No, you're not always going to be given the concentration of a substance. So we need to understand that this could get a little bit more complicated if we wanted it to. Sorry, Idris. Yeah, me here. Because that's the concentration of calcium. We'll talk about another example here in a second. Idris, can I move on? Yep. Okay, let's try this. Now, we're not going to use our intuition. We can, but we're just going to try and solve this using like a little bit of elbow grease here. What is the amount concentration of aluminium ions and sulfate ions in a 0.4 mole per liter solution of aluminium sulfate? So let's think about this. If aluminum sulfate splits up, what's it going to split up into? Aluminum ions, aluminium ions, and sulfate ions. But the problem is, you have to figure out how many are going to split up. So let's start with the formula for aluminium sulfate. How do you get the formula for aluminium sulfate?
Al2SO4 bracket 3.
Good. Aluminum is 3 plus. Sulfate is SO4 2 minus. Hey, if you're not looking in your data booklet right now to see what aluminum and to see what sulfate is, then you're getting left behind right now. Because everybody else, the more you look in your data booklet, the more you find these charges, the better you'll know them and the quicker you'll be on exams. So we've got Al3 plus and we've got sulfate. How can I combine these things to make a neutral compound? So when this thing dissolves, how many aluminums and how many sulfates are we going to get?
2 aluminum.
We're going to get 2 aluminums and we're going to get 3 sulfate ions. So we're going to get 2 aluminum ions and 3 sulfate ions. So far, is everybody kind of okay with this? Yep. What I'm going to do is I'm going to start summarizing, and this is going to be really important for something that we call stoichiometry a little bit later on. But I'm going to start summarizing information. Below my reaction, anywhere where I have a piece of information, I'm going to put it below the substance that it belongs to. So let's read the question. Is there any information here that I can attach to one of these things? The 0.40 moles per liter. This number belongs to which substance?
The aluminum sulfate.
The aluminium sulfate, or the aluminum sulfate, right? So, if we want to do this, it says calculate the concentration of aluminum ions and sulfate ions. What do you want to do first, aluminum or sulfate? Aluminum. Let's get the concentration. What's concentration always measured in? What? Moles per liter of aluminum ions. Do you see any information about the moles of aluminum ions in this thing? Yes. I see the molar ratio. The molar ratio is hidden, right? It's always unknown over given. Our molar ratio is always the unknown substance over the given substance. So the unknown substance is our aluminium. That means 2 moles of aluminium ions will be made for every 1 mole of Al2SO4 3. Now I totally understand that adding these things makes a lot more work for your work down here. Do you agree? Every time I add like a substance attached to a unit, it's like making things bigger and bigger and bigger. Would you agree with that?
Mm-hmm.
But it's very necessary and it will organize our information really well. So I want moles per liter of aluminum. So I want moles of aluminum on top, and I want to cancel out moles of aluminum sulfate. Where do you see moles of aluminum sulfate anywhere? 0.40 moles of aluminum sulfate per liter. Moles of aluminum sulfate for every 1 liter. Do you see how this is getting bigger and bigger and bigger every time I add a substance? But it's important that you keep writing it down. So we got moles of aluminum sulfate and moles of aluminum sulfate cancel out.
0.3.
What are my units going to be for this?
Mole per liter.
I'm going to get moles per liter of what substance?
Aluminum.
Of aluminum ions. And that's how you know you're pretty sure I got this right, because the units are telling you exactly what you wanted to see. So what is it? 2 times 4. What's that? 8. So 0.80 moles per liter, right? But is that exactly what you would expect from this?
Yes.
Yeah, that's exactly what you expect. If we started with 0.4 moles of this, then we would end up with double whatever we started with. Double that, so 0.8 mole per liter. Now, I don't want to do the sulfate. I don't want to do the longhand version of the sulfate, okay? But what's the concentration of sulfate ions going to be?
1.20.
Triple it, so 1.20 mole per liter, or just 1.2 moles per liter. Yeah, Stephanie?
Quiz and you just did it the easy way because you know how to do it with it wrong.
If this was a quiz and you just did it the easy way, I would be totally fine with that. If you used your intuition, that would be absolutely fine, okay? But here's the problem. Not all of your questions are going to be easy.
Yes.
Would you agree? Would you agree? If I give you the concentration of the substance, it's pretty darn easy to get the concentration of the ion. As long as you know the molar ratio, right? That's the key. As long as you know 2 of these for every one of these, or 3 of these for every one of these. Let's think about what mass of magnesium bromide must be dissolved in 1.5 liters in order to make a bromide ion concentration of 0.30 moles per liter. Holy hell, this just went from 0 to 60 in no time. What I want to ask you is what's really the only couple pieces of information that they're giving us, Wim? The volume of the solution, they're giving us the amount concentration of what? What substance? Bromide ions. But it's asking for a totally different substance, magnesium bromide. Does it make sense that when magnesium bromide splits up, it's going to make some magnesium ions, but it's also going to make some bromide ions? So that's where I would start. I would always try and start. If it's asking you a question, this substance, something, 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 this substance, I would always try and write out a reaction. If it's giving you something to do with one entity and it's asking you about a different entity, we need to write out a reaction. So, magnesium bromide. What's the formula for magnesium bromide? Wim? MgBr2. I want to ask you, I'm not being cruel, but can you solve this question properly if you don't get this formula right? No. If you screw up at this stage, you're totally hooped. Straight out of the gate. Do you understand now why I was trying to tell you at the beginning of the semester, going from a name to a formula is the most important thing that you will know. That is the we had a quiz on Friday in our Chem 30 class, and some kids got 6 out of 10 because they didn't know how to go from a name to a formula yet. Still, I mean, I don't know what to tell you, but how many magnesiums are we going to make? Magnesium 2+. And how many bromides are we going to make? 2 Br minuses. I want you to tell me what pieces of information can I summarize? What pieces of information belong below these entities here? Idris?
Is it the 0.30 moles per liter under the magnesium bromide?
Is it under number 1, 2, or 3?
Who knows?
One.
It's 0.3 moles per liter of what?
Bromide ion.
Bromide ion. Where do you see bromide ions here? The last one. 0.30 moles per liter of this substance. Now, what you have to understand is the whole solution is in a 1.50 liter container. That information doesn't belong to any one thing. It belongs to everything, right? Everything is contained in 1.5 moles per, or 1.5 liters. Okay. Well, that's all we were given. So let's start. What are you looking for? The mass of what substance? So we're looking for the mass typically measured in what unit? Grams of magnesium chloride. Do you see anywhere grams of magnesium chloride?
Is it bromide?
Yeah.
Bromide.
Do you see anywhere grams of magnesium
We
bromide?
can get the molar mass.
You have something so closely related to mass. What's so closely related to mass? Molar mass, right? So calculate for me the molar mass. You guys are groaning right now, but this should be an automatic. This should be like adding 2 plus 2. It should be that easy for you by now. What's the molar mass of magnesium bromide? If I can do it faster than you without a calculator, we're hooped. Ah. I wanted to get it away from me as fast as possible. 24.31. Bromide 79.9. $184.10? 0.11. No! You moron! Forgot that one, Jana. You gotta go, you gotta go. Okay. So, do we have something related to the mass of magnesium bromide? Or magnesium, is it?
It's bromide.
It's bromide. Oh man, bromide. Okay, so 184.11 grams of magnesium bromide for every 1 mole of magnesium bromide. I know I'm complicating things, I get it. I know I'm making it longer for you by adding those substances in there. But it's important for us to do that. Hey, if I want grams of magnesium bromide, what do I have to cancel out? Moles of magnesium bromide. Do you see anywhere in here moles of magnesium bromide? I know 1 mole of magnesium bromide is equal to how many moles of bromide? 2. That's our molar ratio. It's the unknown substance divided by the coefficient of the given substance. So this is 1 mole. And I'm just going to move it down because I'm running out of room. 1 mole of magnesium bromide for every 2 moles of bromide. What happens to our moles of magnesium bromide? They cancel out. What are we left with on the bottom that we don't want? We don't want this thing on the bottom. Moles of bromide. Do you see anywhere else where we have moles of bromide? 0.30 moles of this stuff per liter. 0.30 moles of bromide for every 1 liter. So my moles of bromide cancel out, moles of bromide cancel out. And what are we left with?
Liters.
Do you want liters on the bottom? Let's go back to the beginning. Do you want liters on the bottom? No, so what do you have to cancel out? Liters. With our 1.50 liters. Okay, I'm asking you, does this process kind of a little bit make sense? It's knowing where to get these different puzzle pieces, and it's knowing how to organize your information on top that helps us. So, please double check. Put this into your calculator. 184.11 times 0.3 times 1.5 divided by 2. You get 41 grams. Yeah, you gotta go, you gotta go. Yeah? Okay. Is this even a little bit kind of difficult? Yeah, I would agree with that. This is one of the most difficult things that we've done so far to date. Totally. What was the first thing we had to do?
Write the formula.
We had to write the formula of a compound. Straight out of the gate, probably, and I'm not trying to be mean, but probably 20% of us are going to mess that up. Just because you didn't believe me at the beginning of the semester that it was going to be that big of a deal, and you never put in the work. And so now you're kind of panicking, okay? But once you have your dissociation equation, then there's still lots of stuff that you have to be able to pull out of this thing, right? Your molar ratio the 2 to 1 or the 1 to 2? What do I have to do? Hopefully everything gets a little bit easier. The more information you put attached to your units, the easier this becomes. Trust me. Does it make sense? Moles of magnesium bromide cancels out with moles of magnesium bromide. Yes, it's telling you exactly what you have to put on the top and what you have to put on the bottom. What I would like you to do, I would like you to try, is I would like you to do these. Those are easy. These you can do with intuition. These you can do for the most part with just kind of times by this, times by that. But question 18, I would like you to really try that. So just try these 3 really quickly and then try question 18. And then that's probably all we're going to be able to do today. Where did your leaders? Oh, what you did is you put moles per liter. Moles per liter per liter. Remember liters, like moles per liter, liters are going to go down.
Yeah.
So you have moles per liter. You still need to cancel out liters with your
Oh, okay.
So now liters.
Okay, thank you.
Yeah. Some of you are still doing this. I just want to bring your attention to something. Some of you are still doing this. If you were to write, I don't know, 0.41 moles per liter, 0.41. Some of you are still writing this.
No.
What is wrong about this?
You gotta put the formula on top.
You're putting like a fraction inside a fraction, right? Remember, this moles per liter really means moles over 1 liter, right? So don't do both of them. Don't write this weird angled fraction on top of another fraction. Just write moles on top and liters on the bottom, or flip it if you have to. Okay. Let me know if you have any questions. Yeah, it's saying you have a solution to this. You have to be the only ones that know that it's going to split. I would, if you didn't immediately know what to do, if it was saying, find the amount of concentration of each ion, well, the only way you get ions out of this is if it splits up, right? So I would do dissociation.
Okay, and then from there,
And then,
each one, so then I would do one for any.
yeah, no, you don't have to do all of the work that we've been doing, you can use your intuition. But if you're having a tough day, if your intuition isn't working, then you can put in the work. That's totally
Yeah,
fine.
I gotta put in the.
Sure. Put in the work.
Why is it two?
No, why? Why do we not put S8?
We're taking sulfate from this one.
It's not sulfate,
It's
sulfate.
yeah, sulfate.
Yeah, but S8 only refers to pure sulfur as sulfur atoms. Are these sulfur atoms? They're ions. So ions don't follow Hofmann and they don't follow fluorescence.
Next question.
Oh my God. What do you? That is correct.
What did I do wrong? Because I had to do
What do you
what did I not
For
do?
every one Na2S, you get 2 Na moles. You times it by 100.
Oh,
That's not percent. This is moles. You did it percentage.
Well, no, because I just say like this.
You shouldn't have done anything. 2 times 0.11, and you don't even need to divide it because it's all ones.
yeah, and I did divide it. Yeah, like
So you did 2 times 0.41.
Okay, whack. So I did do it right, just forgetting. I must have been.
You did. You did 2 times 0.41.
But you can do 3.6.
That's just dumb kernel for me.
Times 10 to the power of 7.
Did it work at all?
Or
This is at 57, mine is at 56.
Just leave it. So I might get a write up. I'll text you.
does your answer
It's not too hard.
does your two digits yeah, we're done. So 37 seconds. So you don't have to.
It doesn't round it up.
Yeah.
I don't know. It's you. So I don't know. Did you calculate the concentration of each ion, John, or did you calculate the concentration of the original substance? It's moles,
Oh shoot, no.
right? Now you have to get the concentration of each ion. The review? Yeah, and it's up on Google Classroom. Okay, hopefully you got, I'm just going to kind of summarize this first question. Hopefully you got, for A, the concentration of sodium ions. Do you know, have we ever used the square brackets before? Okay, square brackets, they mean concentration of this thing, okay? So concentration of sodium ions is double this thing, right? So 0.82 moles per liter. And the concentration of sulfide is just 0.41 moles per liter. Was that okay? We're okay with that? The concentration of the strontium ions is 1.2 moles per liter because it's a 1-to-1 ratio. The concentration of the nitrate ions is 2.4 moles per liter. And then here, this is the trickiest one, right? Sorry, the concentration of ammonium ions is 0.39 moles per liter. And the concentration of phosphate 3 minus whole 8 is just 0.13 moles per liter. All I'm doing is I'm knowing, okay, this thing splits up into 3 of these, so it's 3 times the original concentration. Question 18, again, there's still like 4 or 5 minutes left, so try it out, and then maybe we'll go over it at the beginning of tomorrow's class. There's this question, there's another practice question after that too, if you're done. There's no assignment from today's.
Fine.
Yep.
How about you?
Yeah.
How about after you go to
250
one, you go to the place we're doing the
Oh.
Japanese?
Like, I don't know
Okay.
if that's right.
So you got 1 whole
How
plus.
much? Can I just like skip it?
Why would you say that? Why would you have that?
Habit. Do you bring money? I'm in next semester, so
Okay.
so
Oh, sorry. One mole of I just want to check it out. Yeah. And then you
see my agenda.
one, and then you want to toss whatever ball.
I am in boxing.
So I don't know. Is this 1 meter?
That's agenda.
So I put that to the bottom. Okay.
Because what is this? Where did you get this 1 meter?
Consider this I'm mobile.
Yeah,
Because it
but
said meters there. So I was like,
yeah, so you'll get meters from here.
What time?
I want to see if it's the same question. Start. Okay, so let's. I'm gonna. Okay. Okay.
yeah, that's what I.
Okay. Yeah, I would say that. I would put 2.0 as it belongs to it. You don't have to, but that's the thing. And then you have 250 milliliters, but that belongs to everything, right? Because it's all in the same area.
250 it's for, is it for iron chloride?
It's for everybody, like, because everything is inside this 200 milliliters, right? So it doesn't belong to the right? Okay, so what do you want?
I don't have spares and
You want the concentration of each ion, right? So let's start off with maybe, do you want chloride or iron first? So say you want the concentration in moles per liter of every 3 moles, right? Do you see anything that has moles of any molar mass, but that's only if we have the grams of mass. Right? And you want moles of iron. And I see moles of iron.
I did study that. That was great.
That's really, oh, it's 1 mole of every plus for every. And we'll go over it again together, all together. We're gonna get some more practice at this.